Hello friends, today we are going to learn about mechanical translational system in control systems. So it is the very most important topic in our control systems subject. So this is the problem given for us in mechanical translational system. So they are asking us to write the differential equation governing the mechanical system shown in figure and determine the transfer function. So this is the given block diagram. From this we have to find the transfer function. Chalo, let's solve this question. So first step is to consider mass m1. Let us draw the free body diagram for the mass m1. This is the mass m1 and we have the variable x1 for mass m1. What we have other things are f of t equals to 0 because we are having f of t on the mass m2. That is what here f of t equals to 0. And first we have to give fm1 for this mass itself, and we have k1 on mass 1. K1 is nothing but spring fk1, and we have b is nothing but dash pot fb1, not b1, fb1, and we have b1. That's all. We also have fk1, the spring between m2 and m1. So this is the free body diagram for mass m1. So now apply Newton's second law. What is Newton's second law? It states that the sum of applied forces is equal to the sum of opposing forces on the particular body. So the force balance equation is f of t equals to, write all these things, fm1 plus fk1 plus fb plus fb1 plus fk. So this is the force balance equation which we consider for mechanical translational system. We don't have f of t here, so it is 0 equals to f1 plus fk1 plus fb plus fb1 plus fk. Now write the differential equation form. So here we have three things, right? One is mass, one is dash pot, and another one is spring. For mass, the differential equation form is F is equals to m into d square x by dt square. For dashpot, how the dashpot looks like? So this is the dashpot. We have f equals to fb, and the DE form is f is equals to b into dx by dt. For spring, this is the spring we have. F equals to fk, and the differential equation form will be f equals to kx. Very simple. So let us assume this equation as equation number 1. Now write the differential equation form for this equation 1. Here Fm1 means mass. For mass, what we write differential equation form? M into d square x by dt square, right? M1, because we are writing for mass 1. D square x1 by dt square. X1 because the variable is x1, plus k1. K means spring. For spring, what we write? For spring, we write differential equation form f equals to kx. That is k1 x1. K1 for this spring k1, and x1 is the variable, plus fb. B means dashpot. For dashpot, the differential equation will be f equals to b into dx by dt. That is b into dx1 by dt, plus the same thing b1. So here we get x1 minus x, b into x1 minus x, because the dashpot b is lying between m1 and m2. When we are calculating for m1, first preference should be given for x1, the variable which is related to m1. So next b1. So b1 is having for m1, right? So we need not to consider for m2. b1 into dx1 by dt, plus we have fk means spring. The fk, k is lying between m1 and m2. When we are considering m1, we have to give preference to m1 itself. So now k into x1 minus x equals to 0. F of t value is 0. So this is the equation number 2. So now step 2. Consider mass m2. So this is the free body diagram for mass m2. So the variable which is associated with m2 is x, and f of t, yes, we have f of t on mass m2. First we have to give m2, that is fm2, and then what we have, fb, and we have k, fk, and we also have another thing, that is b2, fb2. Now here also apply Newton's second law. So the force balance equation is what we have, f of t equals to fm2 plus fb plus fk plus fb2. So this is the equation number 3, let us assume. So now the differential equation form for this f of t equals to fm2 means f equals to m into d square x by dt square. Here the variable is x. So now b, you know that b existing between m1 and m2. So with respect to m2 now we are calculating, so we have to give priority to m2. So now b into d x minus x1 by dt plus fk. K was existing between m1 and m2. So k into x minus x1 plus b2. b2 is individual, b2 is only for m2. So b2 into dx by dt. So let us assume this as equation number 4. So step 3 is apply Laplace transform to equation 2 and 4. What we have, equation number 2, so for your convenience I have written this equation number 2 here, and you have here equation number 4. So apply Laplace transform to equation number 2. What we get, m1 into, we have d square x1 by dt square, that means s square into x1 of s plus k1 into x1, that is k1 is constant, and x1 of s plus b1 is constant, dx1 by dt1, Laplace transform of, that is s into x1 of s plus, we have two terms here, so b into, for first one dx1 by dt, that is s into x1 of s, minus for second term d into, we have minus dx by dt, that is s into x of s plus k into x1, first k into x1 of s minus x of s equals to 0. Okay, so this is the equation number 5, let us assume. So now apply Laplace transform to equation number 4, that is f of s equals to, f of t turns out to be f of s in Laplace transform, equals to m2 into d square x by dt. For this we will write m2 into s square x of s plus b into x of s minus x1 of s plus k into x of s minus x1 of s plus b2 into s into x of s. So let us assume this as our equation number 6. From equation number 5 we can take x1 of s common. So from equation number 5 take x1 of s common. Then we get x1 of s m1 s square plus b1s plus k1 plus bs plus k minus the remaining term x of s bs plus k equals to 0. So from here x1 of s into m1 s square plus b1 s plus k1 plus bs plus k equals to, take this to the right side, then x of s bs plus k equals to 0. Then we need only x1 of s. Then x1 of s equals to, take this to down, then we get x of s into bs plus k by m1 s square plus b1 s plus k1 plus bs plus k. So this is the x1. But this is not the final answer. We need transfer function of the system. Now from equation number 6, this is the equation number 6, take x of s common. Then we get x of s m2 s square plus k plus b2s plus bs minus x1 of s k plus bs equals to f of s. After taking x of s common, this is the term. We have x1 of s, then substitute here, then we get m2 s square plus k plus b2s plus bs minus x of s bs plus k by m1 s square plus b1s plus k1 plus bs plus k. This is only x1 of s. Then we have this k plus bs also we have, that k plus bs equals to fs. Now take x of s common from this both the terms. Then we get x of s m1 s square plus b1s plus k1 plus bs plus k. This is one term, and the other one is m2 s square plus k plus b2s plus bs minus bs plus k whole square by m1 s square plus b1s plus k1 plus bs plus k equals to f of s. Now what is transfer function? Transfer function is output by input, right? Transfer function is x of s, this is from output side, then by f of s equals to, just take this here, this to right side, then we get m1 s square plus b1s plus k1 plus bs plus k by m1 s square plus b1s plus k1 plus bs plus k, m2 s square plus k plus b2s plus bs minus bs plus k whole square. So this is the transfer function of the given mechanical translational system. Thank you.